So in this video, we will learn how to integrate partial fractions, and let's get started with this example. So here we have a fraction over a quadratic function. So first step here is to factor this. So what two numbers um, multiply to 10 and add up to minus 5? There is going to be minus 2 and minus 5. So it's going to be, I'm going to remove this now, brackets x minus 2 and x minus 5. So now we are done with the first step. Now this next step is to find out what is the highest power of x in the denominator. So the highest power is going to be x squared. So the highest power is 2, right? So this indicates, or this tells us, that there will be two unknown value numbers, or values for a plus b, and the denominator of these unknowns will be the roots of the denominator. So here x minus 2, and for b it will be x minus 5. And actually, first just ignore the integral for now, and let's do the partial decomposition first. So we will bring the integration later onwards after we're done with finding a and b. So now what do you think we should do to find the values of a and b here? So one thing we can do here is multiply the entire thing by x minus 2 and x minus 5. Oops. Oh, x minus 5. And what this will do is it will get rid of this first of all. So we will be left with 7x minus 23 is equal to, now a over x minus 2 will be multiplied by x minus 2 and x minus 5, right? And we can cancel out x minus 2. So now all that will be left for this one, oops, will be x minus 5, and for b it will cancel out this for x minus 5 for b, and we will be multiplying x minus 2 with b. And the other method of this actually is the cover-up method. So instead of doing all this multiplication, when you are simplifying and writing in this format, let me actually erase this. So once you're on a, you look at the denominator of a, and you see this left equation, and you cover the denominator of a here. So if we cover the denominator of a, we will have x minus 5 as left over, so we can directly multiply that. And the same thing for b will be b into, what is the denominator of b here? It's x minus 5, so we will cover that up and we will be left with x minus 2. So that's there. Now how do you think we should solve for a and b here now? So now comes the roots now of a and b. So let's substitute 5 for x here to find out, or maybe 2 first. So we find out a first. So once we substitute 2, we will get 14 minus 23 is equal to a into 2 minus 5 plus b into 0, and this part just cancel out. So we will get minus 9 is equal to a into minus 3, and a here is equal to 3, since negative 9 divided by negative 3 is just 3. And for b, we can substitute 5 in x, so we will get 35 minus 23 is equal to a into 0 plus b into, it's gonna be 5 minus 2, so 3, and solve for b now. So it will be, this part here is 12 is equal to 3b. Oops, I think, no, yeah, it's fine. So b here then will be equal to 4. So now we can go back to our equation of a plus b, and we can substitute a and b here. So now we can finally integrate actually. So a here is 3 over x minus 2 dx, plus integration of 4 over x minus 5 dx. Now let's cover some basics. So the integration of 1 over x here dx is, what is it, ln x, absolute value of x. And we also need to use absolute value since we cannot have a negative number inside ln, since that will give us an undefined answer. So always remember to use absolute value, and this is the general integration for 1 over x or anything else. So let's say we have integration of x minus 5, so dx, this will be equal to ln absolute value x minus 5 ln, x minus 5 absolute value. So here we can do the same thing. So the answer will be, we can take 3 outside, so 3 ln absolute value x minus 2 plus 4 into ln x minus 5 plus c, don't forget the c, the constant. And that's it. This is the answer. So you can pause the video and try to do the next example yourself. So here we have 3 roots in the denominator. So again, let's start with the most basic first step, which is what is the highest power of x in the denominator. It's going to be x to the power of 3 once it's like multiplied everything. So this indicates that we have 3 unknowns. It's going to be a, b, and c, and we know that we have 3 roots also. So 3 distinct roots, meaning that we will have a over x minus 1, sorry, plus b over x plus 1 plus c over x plus 3, and we can leave the integration sign for now and solve for a, b, and c first, and then we'll integrate it later onwards. So again, as before, we'll repeat the same steps again. We will multiply the entire denominator by both sides, so we will be left with x squared plus 4x plus 1 is equal to a into, now we cover up x minus 1 here in this equation, so we will be left with x plus 1 and x plus 3. Oops. So now moving on, so b now, and we will cover up x plus 1 here, so we will be left with x minus 1 and x plus 3, so x minus 1 and x plus 3. Now finally, I need more space here. Oops. Yeah, c into, now we cover up x plus 3, so we'll be left with this part here, x minus 1 and x plus 1. Now it's a very simple step of substituting the roots in x and finding the value for a and b and c. So let's start with 1. So when x is equal to 1, so we will get 6 here is equal to, and these two are going to be 0 because x minus 1 is here and x minus 1 is over here. So 6 is equal to a into 2, and here we will have 4, and a is gonna be, I'm just gonna directly solve it, it's gonna be 6 over 8, and that's 3 over 4. So we found one of the unknowns. Now moving on, let's substitute the next root for x. So let's do minus 1, and we will get that minus 2 is equal to b into minus 2 into 2, and therefore b here is equal to half. Yes. Now for c, we are going to substitute minus 3, the other last root for x, and we will get c is equal to minus 1 over 4. So these are the 4 values So a is 3 over 4, b is half, c here is minus 1 over 4. Let me write that better. So this is an example where we have distinct real roots. So there in the next few questions I'm going to do some questions with imaginary roots or repeated roots where we need to see the multiplicity number. So here this is a very easy example actually, and I'm just gonna solve this now finally because we found a and b and c. So I'm going to remove or erase all the workings below and integrate the answer now. So it's just going to be the integration of this part over here, and this is equal to 3 over 4 ln absolute value, this is very important, don't forget this, x minus 1 plus half ln x plus 1 and minus 1 over 4 ln x plus 3 plus c. Now let's do an example where we have a real root which is repeated. So a repeated real root. So in the next question we have an integration of a fraction, and we can notice that in the denominator here we only have a one real root, and we have also a multiplicity number here. So let's start as we did from before. So the highest power of x in the denominator is going to be 2. So this means that we have two unknowns which are a and b. So we can write them over here, a and b. And as I mentioned before, we have the multiplicity here as 2. So there will be a repeated root here. So one of the denominators is going to be x plus 2, and the other denominator for b is going to be x plus 2 squared. Since we only have one root and it is being repeated and there is a multiplicity number over here. So let's say, for example, it was x plus 2 to the power cube. If this will be, we have the highest power as x to the power 3, so it will be 3 unknowns, a, b, and c, and the denominator for each of them, first one will be x plus 2, next one will be x plus 2 squared, and for c it will be x plus 2 cube. So I hope this is clear, and you can see the difference of this question compared to the last one, since this question only has one root, and like this question there are different roots for each of the unknowns. So now continuing on, so that's it for this one. So let's get rid of dx and integration and first do the partial decomposition. So this is how you make the decomposition for a real repeated root. Is going to be a over x plus 2 plus b over x plus 2 squared. And now as before, we will multiply the entire thing by the denominator here to get rid of it. 6x plus 7 is equal to a into, now we will cover up x plus 2 in here, so we will only have one x plus 2 as the remainder, x plus 2 plus b into, now we need to cover this up in this part, so we will only have one as the remainder. And if this cover up method is not clear for you, let me just do this then. We will multiply both sides by x plus 2 squared, and here when we do a over x plus 2 multiplied by x plus 2 squared, what will be the answer? It just cancel out, and this part will cancel out, and it will be left with this part. And for b here, it will simply be x plus 2 squared multiplied by x plus 2, so this entire thing cancels out and we only have b. So that's simply what the cover up method is. So now we simply solve for a and b again. So for let's substitute x is equal to minus 2, as this is the root, and we will get that b here is equal to minus 5. And let's substitute 0 now to solve for a now. So we will get 7 is equal to 2a plus b, and we know from before what is b, which is minus 5. Sorry about my handwriting, I know I'm not the greatest. A is equal to 6. So now let's go back here and substitute 6 here, and here will be minus 5. So now the only step which is left now is to integrate this. So I'm just gonna get rid of the brackets dx and integrate dx. So the first part is just gonna be 6 ln absolute value x plus 2 plus, how do we derive this now? Because we cannot, this is not ln x, by the way, since there is a power of 2 here. So what we can do here is, let me just, yeah, we can bring this part up, so it will become x plus 2 minus 2, and now we can derive this. So we can take actually minus 5 also outside. So let me just write it outside here actually. Okay, I need more space. I'm gonna clear my screen and then come back. So as I was mentioning before, so we'll bring x plus 2 squared up in the numerator. So it'll become x plus 2 minus 2, and now we can integrate this, so it will become x plus 2 minus 2 plus 1 is minus 1 over minus 1. So this minus sign can cancel out, and we will get actually plus 5 plus 5 over x plus 2, since we can just bring this down, and we need to add c, and this is the final answer. Now let's do an example where we have imaginary roots, where we cannot factor, there is no factor or root for x. So in this next question is going to be a little challenging rather than the other questions that we did. So now first thing is to find the highest power of x in the denominator. Is going to be x squared, and there is an x squared here, since if we expand this we'll get another x squared, and the highest power then will be x to the power of 4. So we know that there will be 4 unknowns this question in this example, a, b, c, and d. And now the next thing you can notice is that the only factor in the denominator for x here is going to be 1, which is this part over here. X squared plus 1 can never be factored. It's an irreducible equation. You can substitute anything for x here and you will never get to factor this. So this will stay the same in the partial fraction. So one of the denominator will be x squared plus 1, and the other one is going to be x minus 1, this part, and the last one is going to be x minus 1 squared, since we have a multiplicity over here. Don't forget that we did that in our last question. Now the next thing that you need to know is, you would notice that we have 4 unknowns and we only have 3 fractions. You notice that? So whenever we have a denominator with the power x power of 2 or more, the numerator is going to be ax plus b. Ax plus b, and these two are going to be the same. So again, as I mentioned before, whenever we have an exponent or power of 2 for x, is going to be ax plus b. And you might notice that this is the same format as the line equation, so mx plus b, and here is just ax plus b. So and also another question that you might be thinking is, why is it not the same case for this part over here? Since this 2 is just the multiplicity, it is not an irreducible equation such as this one. So that's it. And again, now the same steps for multiplying both sides with the denominator and solve it for a, b, c, d. This one will be more challenging since you only have one root. So let's start with that. So it's going to be minus 2x plus 4, and I would need more space actually. So minus 2x plus 4 is equal to a, okay, let me write the fraction, ax plus b into, now we will cover up x squared plus 1 in the denominator for this part. So what are we left with in the denominator here? So it's going to be x minus 1 squared. Now moving on, now we need to cover up for c, and we need to cover up x minus 1. So what are we going to be left with if we took out 1 x minus 1 here? This is going to be x squared plus 1, and there will be x minus 1 since we are only taking out one of them. And for d, actually let me write it more clearly. I'm sorry about my handwriting. I'm not understanding my own handwriting right now. Yeah, okay, so plus d, and we are gonna take out, cover up x minus 1 squared. So once we do that, we'll only have this part over here and x squared plus 1, and that's it. So now we just need to keep substituting values for x and solving for each of the unknowns, and we only have one root, keep that in mind. So let's start with that now. So of course the first step is to substitute the root itself. So once we substitute x is equal to 1, we will get that 2 is equal to 2d and d is equal to 1. So we already know one of the unknowns. Because of that we had one root. Now moving on, we now need to substitute random numbers in x and get linear systems and then figure out how to solve for the unknowns. So the easiest numbers are 0, 1, 2 and 0, negative 1, negative 2. So let's start with 0 now. So we will get is 4 is equal to b minus c plus d, and we know that d is 1, so we can change this to 1 and we get the equation that 3 is equal to b minus c. Now moving on, let's substitute 2 in x. So we will get minus 5 is equal to 2a plus b plus 5c. And moving on now, so let's substitute minus 1 now. So we will get is 1 is equal to minus a plus b minus c. And you might notice that we know what is b minus c. So here we can substitute 3 by b minus c and get the value of a. So let's do that now. So a is equal to minus a, or 1 is equal to minus a plus 3, and here a is going to be equal to 2. Now we can replace a with which equation is it? This part over here, and we will get a linear system for b and c, and we can then solve for b and c. I'm not going to go into much detail since that's just algebra or calculus, simple calculus. So we'll get b as 1 and c as minus 2. So I meant this equation, by the way, minus 5 is equal to 2a plus b plus 5c, and we can substitute a in here, so it will be minus 5 is equal to 4 plus b plus 5c, and then you can solve for b and c since we have half of it over here. And these are the values for a, b, c, d, and we can go in the equation now and replace them. So a was 2, b was 1, c was minus 2, and d was, where's d, is 1. So now all that is left is to integrate this now. So let me just get rid of all this working, all the workings, and now let's integrate the last step, which is the easiest step. Integrate dx, and okay, so now we need to find the integration of 2x plus 1 over x squared plus 1. Now you might be wondering, how do we integrate this? Since if we take u here as the denominator, is going to be u is equal to x squared plus 1 du is equal to 2x, and you cannot cancel out the numerator since there is a plus 1 here, and any other method would not work. So we actually need to split this integration or this fraction into two parts. So one part is going to be 2x over x squared plus 1 plus integration of 1 over x squared plus 1, and this is a trigonometry identity of tan inverse x, and the integration of minus 2 over x minus 1 is just going to be minus 2 ln absolute value of x minus 1, and this part is just going to be, I'm going to quickly do it here, x minus 1 minus 2, and integration will be x minus 1 minus 1 over minus 1, and it will be minus 1 over x minus 1, and that's it. So, and for integrating this part over here, oh yeah, let me just write this quickly. This integration is tan minus 1 x, and here we can take u now, since now it will cancel out the numerator. So u is gonna be x squared plus 1, du is gonna be 2x dx. So it's gonna be the integration of 1 over u, since 2x is gonna cancel out with this part, and yeah, and the integration of 1 over u is just ln u, and now we can substitute u as the value before. So the final answer is gonna be ln x squared plus 1 plus tan inverse x minus 2 ln x minus 1 absolute value minus 1 over this part over here. I forgot to add this, x minus 1 plus c. So this is the last question that we will be doing. We have 1 over x into x squared plus 1 squared. So in this example we have imaginary repeated roots. Okay, let's start. So let's get rid of these because we need to decompose them first. And okay, the first step again is to find the highest power of x here. So it's going to be x squared, which is x to the power of 4 multiplied by x. So the highest power will be 5. So in this question we are dealing with 5 unknowns, and we only have one root here, which is going to be 0, since this is a irreducible fraction, or sorry, line equation. So let's start by writing them down now. So first fraction is going to be the denominator of x, plus the next is going to be x squared plus 1 plus x squared plus 1 squared, since this is the multiplicity number here. Now we know that we have 5 unknowns. So first one is just going to be a. Next one, as the power is 2, is going to be bx plus c. And here again we have a power of 2 on x, so it's going to be dx plus e. Oopsies. Now again, let's multiply both sides by the fraction to get all the unknowns. So it's going to be 1 is equal to a into cover x now in this part. So we'll be left with x squared plus 1 squared plus bx plus c. I'm going to put it in a fraction, of course. Oh, I mean brackets, my bad. Now we need to cover x squared plus 1, so we'll be left with x here, first step, and we will be left with 1 of x squared plus 1 plus now we have dx plus e into, now we need to cover x squared plus 1 squared, so we'll only be left with x now. Now we can do the step that we did in the last questions by substituting random numbers for x here, but we notice that we have 5 unknowns here and it's going to take a while for that. So here I'm going to teach you another method which is not very simple, it's very long and tedious. So let's get started. The first step is to just expand as much as you can. So it's going to be 1 is equal to a into open brackets x4 plus 2 2ab, so x squared and b is just that, plus 1 close brackets. Now this part is going to be, I'm going to multiply this here, so it's going to be x cube plus x, and now multiply with this part here, so we will get bx4 plus bx2. Now moving on, did we forget? Oh yeah, I forgot about c. Oh yeah, so now we need to do c times this part, so it's gonna be plus c into x cube plus cx. Now moving on, this will just be dx2 plus ex. Now let's multiply a inside, so it's going to be equal to, actually we don't need to write the line for that, I'm going to write it right here, a, and this is a here, and this is just going to be a. Oops. Yeah. So this is the expanded version of the equation. Now our next step is to group the x's together where the powers are the same. So we can group a and b together, this a and b, since both of them are multiplied by x to the power of 4, so we will get a plus b into x to the power of 4. Now moving on, let's find all the x to the power of 3. So we only have one x to the power of 3 here, so I'm just going to write it down here, plus now x to the power of 2. So here we do have x to the power of 2, so in a, I mean to say, so it's going to be 2a, plus we do have b x to the power of 2, so b, plus, and the last one we have is d, this part, into x to the power of 2 plus c plus e x, since this and this are together, and last but not least, don't forget about the a here. So now I just want you to, so actually let me ask you a very simple question. So let's say we have a box or unknown x squared plus x is equal to 5x squared plus x. So what do you think the box is? It's very simple, right? It's just going to be 5, since we only have one x squared over here, and the only x squared on the left hand side is the one with the unknown, and we know that it's going to be 5. So that's exactly what we did over here, if you notice. So here, what is the coefficient of x to the power of 4 on the left hand side? Nothing, right? 0. So we know, let me just make more space here, or let me, okay, that's too much. Yeah, as I was saying, we need to look for the coefficient of x to the power of 4 on the left hand side, but we don't have anything, right? So we know that a plus b is equal to 0. Now for cx to the power of 3, do we have an x to the power of 3 on the left hand side? No, right? So c is equal to 0. Now moving on, is there any coefficient for x to the power of 2 on the left hand side? No, right? So it's going to be 2a plus b plus d is equal to 0. Very simple, right? Now c plus e to the, times x, but we don't again have any x on the left hand side, so c plus e is also equal to 0. And we do have a 1, and we do have a constant on the right hand side, so a here is equal to 1. And now we can very easily solve for the unknowns. So a plus b is equal to 0, and we know that a is equal to 1, so b is also equal to minus 1, c is 0, and e is also going to be 0 since c is 0, so e is also equal to 0. Now for b and d, so for d we just need to substitute a here and b, so 2a plus b, so 2 times 1 plus b, which is minus 1, is equal, no sorry, I forgot about d, plus d is equal to 0. So d here is equal to 1, right? Oh, my bad, it's going to be minus 1, since 1 plus d is equal to 0, so d has to be minus 1. Now we have all the unknowns. All we need to do now is to integrate. So let me just clear my screen and write the unknowns. So a is going to be 1, b is minus 1, c is just 0, so we can just take that out, d is minus 1, and e is also 0. So now let me clear my screen and let's integrate this. So integration of 1 over x minus x over x squared plus 1 and so on dx. So the first one is pretty simple. This is going to be ln x absolute value. For the next part, we can take u as the denominator, so u is equal to x squared plus 1, du is 2x, and is going to be over u multiplied by 2 over x du dx, and dx is going to cancel out, so we will be left over with minus 1, let me just, so minus 1 over, I'm going to take out the 2, actually let me just take out minus 1 over 2 outside and just leave 1 over u inside, so it's going to be minus 1 over 2 integration of u, which is going to be ln u, and for this part again we can take u, I think, we can. So again, let's take u as this part, so here is going to be again the same thing, 1 over 2, but except that it's going to be 1 over u squared, and here we take it up, so it's going to be minus 2 plus 1 over plus 1 minus 1, I mean the minus cancels out, and we are going to be left with 1 over 2u, so plus 1 over 2u plus c. Now the final step just left is substituting u back, so ln x minus 1 over u ln x squared plus 1 plus 1 over 2 into x squared plus 1 plus c. And that is the final answer, and this question took a long time. I do have a shortcut method for you guys to recheck your answer from the beginning. So this was the question, right? So integration of 1 over blah blah blah, right? And you have the final answer as what we got over here. So you need a calculator which you can do the integration with two values. So once you type your question, and let's say we substitute any two random numbers, let's say 1 and 2, and we get some answers such as 0 0.1234, or let me just make it more realistic, 937, something like that. In your final answer, we substitute 2 in x first. So everything here, we will substitute 2 first in x, and then we will do minus the same thing, but we will substitute 1. And if we get the same answer as this, we know that our answer is 100% correct. So I will be making a short video on, of course, showing you as how to use the calculator for that function, or how to use the calculator for rechecking your answer, as of course it's more easier to see something rather than talk about it. And thanks for watching. If you have any questions, you can ask them in the comment section. I'll be more than happy to help. And stay tuned, and thanks for watching. See you guys.